open whole setup. So this whole setup is working in C band. The reflex crystal is working in X band. It is written C band solid state source. If it is C band, its operating frequency will be 4 to 6 gigahertz. Okay, which is also comes under your microwave way to approach. And the basic thing is that you have to set a maximum output. Maximum means if you provide here 4 to 7, whatever the potential, you will get less amount of potential at the output. Now we need to connect this whole setup in such a manner that detector mount is there. This is called detector. We have detector mount there also. Here also we have detector. And one filter is there. If unwanted signal need to be removed, this filter will remove. This is called microwave filter. So always the connection, whatever the changes you will do here only, this will remain as it is. So
any particular direction that needs to be connected?
no.
So you can connect either that or
That way.
one of the filters, three filters. Filters.
This is only one filter. So in order to operate this, remember that we have the three, this is the tuning voltage and this is the gain. Need not to change any sort of. So here, if I will change this particular potential, your amplitude will also change. Amplitude change, correct? It is 3.4 point something, it is value. You have to keep all these things in potential. So you have to select one potential which is the maximum. Suppose from minimum I am value. Now what is the output here? Just see that. How much is the output?
6.50.
Okay. Here I am value. It is decreasing. Then it is decreasing. Decreasing. 6.7. Take this one as a reference. 6.48. So reference potential we have selected 6.48 volt. Done. So this 6.48 is the power what we provide to this. This is a strip line. So this strip line having the certain characteristics impedance. So here whatever the device is mount, it is made up of that strip line. First we are making the reference potential. Let us consider this. This power or this potential is provided to each and every device. And then we will take the output of that. So first let's see what is the power divider. This is called power divider. So in this power divider,
We have to take only that for reference. We have to change it.
yes, we have to set one maximum output and then change. So fix this one. Here we have termination. Divide this. Now see. What is the output you are getting? It is just like this. It is P1, this is P2, and this is P3. So P1 we have given 6.48 volt. P2 means this is how much we are getting? 3.96. 96 volt. 3.96. Done. Change this. what is the output?
3.7.
3.8.
3.8.
3.8. So power is divided.
Yes.
If you add these two, how much you will get? Near about 7. Some division was done unequally. So here it is 3.96, here it is 3.80. Okay. In power divider, we have to calculate coupling factor and isolation factor. Okay. So since there are two ports, we will calculate two coupling factors. Coupling factor with respect to R2. With respect to R2. Its relation is 20 log V1 by V2. So 20 log V1 is how much? 6.48 and V2 is how much? 8.96. It will be in dB. Then coupling factor for R3 for this third. So we will get 20 log V1 by V3. Substitute 20 log V1 is how much?
6.48.
And V3 is how much?
3.8.
This much dB. Now what is coupling factor? Coupling factor means when you provide the power in certain port and you get some maximum output in some other port and it correlates that where the maximum is available, that is called as a couple. It is just like that. There are two primary and secondary winding is available. Due to the coupling, the maximum output we are getting. Only we have to tune this number of windings, number of coils. So this is your primary winding and this is your secondary winding. If the secondary windings coils number of turns are more, then it will step up, and if it is less, it will step down. Same it is due to the coupling. So coupling means it is the maximum where it is getting. So maximum with respect to the second port, maximum with respect to the third port. And this port 2 and 3 are isolated with each other. Means if you feed the power at port 2, you will get negligible output at the port 3. Means it is in millivolt. That indicates that it is near about 0. And 0 volt means there is no output. So isolation we will calculate. Now what you will do, remove this. Terminate this port. Connect this. Now how much output we have provided reference is how much? 6.48. Now from this, how much you are getting?
320
So that means V3 is 320 millivolts. What is V2? 6.48 volt. That potential we have given here. So that means it is near about 0. So there is no link up. It is satisfied. Now isolation factor you will calculate 20 log of V2 by V3. So it is 20 log of V2 is how much? 6.48 and this is 0.32. For this much is your isolation factor. Done? So this is about the power divider. Only in this you have to calculate two things. One is coupling factor and is isolation factor. Done? Next one, 3 ports. Now this is one directional coupler. Okay. In directional coupler, we have to calculate 4 parameters because there are 4 ports.
Yes.
One is coupling factor. Second is isolation factor. Third is insertion loss. Okay, and fourth one is directivity. Then it is a 4-port device. Port 1, port 2, port 3, port 4. Now, if you provide the power at 1, then this line is called as a primary line. If you provide the power here, it will become the primary line. Alternate to this, it is called as an auxiliary line. Okay, and your coupling factor will be always related with the primary with respect to auxiliary. So, for example, if you feed the power here, some power will go in this direction, some power will go in this direction. Power will be distributed. Suppose there are two holes are there like this. One it will come here and some power will come here. So signal strength will reduce over here. So maximum output we will get in the port 3. If it is 1. Right? So if it is there, then coupling factor you can find out as 20 log V1 by V3. Right? Then insertion loss will be calculated in the primary winding. Always remember that this will be your insertion loss. So insertion loss is equals to 20 log V1 by V2. Then this is in dB. This is also in dB. Then
So there was two ports, so we have calculated two coupling factors. But then it is four port by we calculated.
because it is a primary winding we are taking. Here it is directional coupler is having 4 different characteristics. It is not power divider. It is a power divider. It divides the power also. But it is having its own characteristics. So directivity means you have to calculate with respect to auxiliary arm. In this auxiliary arm, maximum potential you will see at 3, minimum potential you will see at 4. So it will be ratio as 20 log of V3 by V4. Done. And one more factor is called what? Isolation. Isolation factor will be between 1 and 4. It is 20 log V1 by V2. Done. Now, in order to check these all potential, so what is the reference potential we have given? 6.48 terminate this port. I don't know which is the primary, which is the secondary, which is the auxiliary. So first I will measure the output, then I will decide. So if I will take the output from here, what is the output like?
16.16.
So that means first potential we have got 6.00 volt or 16. Yes. 6.16. What is our reference we have given?
6.48.
6.4. Then now change this. Fix it here. Now see how much is the output? See how much it is?
60 millivolts.
69. Maximum is 69. So this is 69 point. 71 is also coming. 72 is also coming. 84 is also coming. So let us consider 84.6 millivolt. Yes?
Maximum.
Then remove this.
This will be the upper will be the primary line.
Turn off this. Fix up to now how much is the output?
386. 322 millivolts.
Millivolts. So next is 3 millivolts. Then, so which is the maximum out of this? This is the maximum. Then after that, which is the maximum?
Sorry, 4 sir.
Maximum.
Maximum.
This is volt.
Yes.
And these are not millivolts.
6.16.
So this is the 6.16. Then after that, which is the maximum?
4 sir. 322.
अरे यहाँ पे देखो, उसको मत देखो.
322 millivolts.
So this is your 322, and which is the least one?
84.5.
So this is 84. Now you put in this value, you will get all your results. Always remember that wherever the maximum will come, that is your coupling port. After that maximum, which is the maximum, that is called insertion port. And after that least one will come, that is called isolation port. Right. So like this, for this also you have to calculate. For this hybrid one. Try. Ring, you have to vary the potential as per the frequency.
Directional coupler. Directional coupler, VREF, ring resonator, and you have to use all 5.
All five.
Even is 6.484.
Draw a line not to differentiate. You get confused.
Even is 6.48. And then the second one is 3.4.
One right.